Good morning, everybody. Today we are going to solve practice problem 3.6 from Alexander Sadiku's Fundamentals of Electric Circuit. So, this is the circuit given, and using mesh analysis we are asked to find I naught. So, if you notice this I naught, that current is flowing through this 6 ohm resistance. At the same time, it is also marked the I3 current is flowing in this loop. That means this I3 and I naught are the same. Okay. So wherever you come across this I3, it can be replaced by I naught, and hence we can find the I naught. Okay. So here we have one source given and it is diamond in shape. So we'll see what it is before solving that problem. If you can see a diamond shaped symbol, then it indicates it is a dependent source. So it can be a current source or it can be a voltage source. Actually, the voltage or current of this dependent source depends on some other elements current or voltage. Okay. Or we can also say that the control of the dependent source is achieved by a voltage or current of some other element in the circuit. And it is broadly classified as current source and voltage source. Here you see this is a current source. How do you identify it as a current source? Within this diamond shaped symbol, if you have this arrow, then it indicates it is a current source. Within this diamond shaped symbol, if you have this polarities mentioned, then it is a voltage source. And this dependent current source can be of two types. It can be a voltage controlled current source, or it can be a current controlled current source. Similarly, this dependent voltage source can be a voltage controlled voltage source, or it is a current controlled voltage source. Okay, so we have this four basic types. Now we'll try to solve this problem. So using mesh analysis we are going to solve this. We'll check this first loop. This is the first loop, right? So in which current I1 is flowing. So if you take this, we can write it as minus 16 plus 4I1 minus 4I3, because through this 4 ohm resistance we know that this I3 current is also flowing. At the same time, this I1 current is also flowing, isn't it? If we check this 4 ohm resistance, through this 4 ohm resistance, this I3 current is also flowing. At the same time, this I1 current is also flowing. Both are flowing in the opposite direction. So it is minus I3. Then instead of I3, I am going to write this as I0, because we know that this I3 and I0 are the same. Okay, so I am going to replace it by I0, and then this current I1 is flowing through this 2 ohm resistance, isn't it? So it is plus 2 I1. At the same time, the I2 current is also flowing through this 2 ohm resistance, so it is minus 2 I2. That is equal to 0. So from this, you can write it as 6 I1 minus 2 I2 minus 4 I0, that is equal to 16. So if you divide this by 2, then I can write this as 3 I1 minus I2 minus 2 I0, that is equal to 8. So this is our first equation. So for loop 2, we are going to write the equation. So it is 8 I2 minus 8 I3. Instead of I3, I am writing it as I0 minus 10 I0 plus 2 I2 minus 2 I1, that is equal to 0. So it is minus 2 I1, rewriting this, okay, minus 2 I1 plus 10 I2 combining I2's together minus 18 I naught, that is equal to 0. So dividing this by 2, I'll get this as minus I1 plus 5 I2 minus 9 I naught, that is equal to 0. So this is our third equation. Now we write equation for this loop 3. It is 6 I naught plus 8 I naught minus 8 I2 plus 4 I naught minus 4 I1, that is equal to 0. So it is minus 4 I1 minus 8 I2 plus 18 I naught, that is equal to 0. So dividing this by 2 again, because 2 is common in all terms. So it is minus 2 I1 minus 4 I2 plus 9 I naught, that is equal to 0. So this is equation number 3. So we got 3 equations. So this simultaneous equations can be solved. This is first equation, second equation, and the third equation we got. So I'm going to write this as this format: 3 minus 1 minus 2, and here it is minus 1 plus 5 minus 9, and this is minus 2 minus 4 plus 9. So I have written this as 3 minus 1 minus 2 minus 1 plus 5 minus 9 minus 2 minus 4 plus 9 multiplied by this I1, I2 and I0. That is equal to, on this side it is 8, 0, 0. So what is this delta? Delta is equal to 3 into this, cross multiply this, so you get this as 45 minus, when you cross multiply this, this is 36, and then minus of minus 1, so it becomes plus 1 multiplied by, so you are going to cross multiply these two, so it is minus 9, and then minus of minus, so it is minus 18, and then this is minus 2 multiplied by these two, right? So it is 4 minus of minus, it is plus 10 when you multiply these two. Okay, so that is equal to 3 into 9 minus 27 minus 2 into 14, so it is 28. So we get this as 27 minus 27 minus 28. So we get this as minus 28. So what's the answer we got for this delta? It is minus 28. Now to find out I naught, we have to replace this third column by this value, isn't it? So we can find this delta I naught. So that is equal to this is 3 minus 1, first column as such, and the second column as such, return 5, then minus 4. The third column is replaced with this 800. So this is the only value for which we can perform this. So 8 multiplied by this, it is 4, then minus of minus plus 10. So it is 8 into 14, right? We'll keep it as such because it will be easy for us to calculate. Okay, do calculation. So I naught is equal to del I naught divided by del. So it is 8 into 14 divided by minus 28 already we get, right? So it is 2 times, then when you multiply this we'll get this as 4, so it is minus 4. So since it is current, the unit is amps. Okay, so this is our answer. Thank you.